Linear regression is a statistical method that helps to model the relationship between two variables by fitting a linear equation to the observed data. This method is widely used in various fields like finance, engineering, social sciences, and economics. Types of linear regression. 1. Simple linear regression. It models the relationship between one dependent variable and one independent variable. 2. Multiple linear regression. It models the relationship between one dependent variable and multiple independent variables. Now let's dive into some examples to understand these concepts more easily. Example 1. Suppose we want to model the relationship between the height, dependent variable, and weight, independent variable. Here we can use simple linear regression since only one independent variable is there. Example 2. Suppose we want to find out how much increase in sales, dependent variable, will occur if we increase both advertising cost and product price, independent variables. Here multiple linear regression can be used as more than one independent variable is involved in this case. Example 3. Suppose a company wants to predict whether an employee will leave or stay in their job based on factors like salary, years of experience, education, etc. In this case, multiple linear regression can be used. Example 4. Suppose we have a dataset consisting of the age of individuals and their height. Here we can use simple linear regression to model the relationship between age and height. Example 5. Suppose we want to predict the price of a house based on its size, location, and number of bedrooms. Here multiple linear regression can be used to find out the effect of each independent variable on the dependent variable. Linear regression is a statistical method that is widely used in analyzing data sets that consist of continuous variables. It allows us to identify the relationship between a dependent variable and one or more independent variables by fitting a linear equation to the data. One real-life example where linear regression can be applied is in predicting house prices. In this scenario, the dependent variable is the price of a house, and the independent variables could be factors like location, square footage, number of bedrooms/bathrooms, and age of the house. To apply linear regression to this problem, we would first collect data on a number of houses with different characteristics from various locations. We would then plot this data on a scatter plot with price on the y-axis and each independent variable on the x-axis. If there appears to be a linear relationship between any of these variables and price, we can use linear regression to create an equation that will allow us to predict future prices based on these variables. The simplest type of linear regression is simple linear regression, which involves only one independent variable. In our example above, we could use simple linear regression to determine how much impact each individual factor has on house prices. For instance, if we were interested in how much impact square footage has on price, we would fit a line to our scatter plot that best represents that relationship. The equation for simple linear regression takes the form y equals mx plus b, where y is our dependent variable, house price, x is our independent variable, square footage, m is the slope of our line, how much each square foot affects price, and b is our y-intercept, the starting point for our line. Multiple linear regression is a statistical technique used to model the relationship between a dependent variable and several independent variables. Unlike simple linear regression, which only considers one independent variable, multiple linear regression models consider several independent variables. For example, suppose we want to predict a student's GPA based on their previous academic performance, number of extracurricular activities participated in, number of hours spent studying weekly. In this case, GPA would be our dependent variable while the number of extracurricular activities and weekly study hours would be our independent variables. The multiple linear regression model can be represented by the following equation: y equals beta 0 plus beta 1 x1 plus beta 2 x2 plus beta n xn, where, to find these coefficients, we use least squares estimation, a method that minimizes the sum of squared differences between observed values and predicted values. To illustrate how multiple linear regression works in practice, let's consider an example from real life. Suppose we want to predict how well a new restaurant will do in terms of revenue based on various factors like location, menu prices, and customer reviews. our dependent variable will be monthly revenue for the restaurant. To simplify things, let's say we have three independent variables: location, in terms of average income in the area, menu prices, and customer reviews, on a 5-point scale. We collect data on the monthly revenue of several restaurants, along with their location, menu prices, and customer review scores. We use this data to build a multiple linear regression model to predict revenue for a new restaurant. Industries using linear regression include: 1. Healthcare. Linear regression models are used to analyze medical data such as patient outcomes or drug effectiveness. For instance, hospitals and healthcare organizations use this technique to predict the likelihood of readmissions or complications after surgery. 2. Retail. In the retail industry, linear regression analyses are used to predict customer behavior patterns based on past sales data. For example, retailers can use this model to determine which products will be popular during a particular season and how much inventory they need to stock. 3. Finance. Financial institutions use linear regression models for risk management and forecasting financial trends. The analysis can help banks determine which investments are worthwhile based on previous performance. 4. Education. Educational institutions use linear regression models to predict student performance based on various factors such as demographics and attendance records. 5. Manufacturing. Manufacturing companies use linear regression analysis for quality control purposes by identifying defects in products before they become major problems. 6. Agriculture. Farmers use linear regression analysis to predict crop yields based on environmental factors such as temperature and rainfall. In this video, we will discuss the prerequisites for learning linear regression. These are the fundamental concepts that you need to understand before you can begin applying linear regression to real-world problems. 1. Basic statistics. Before you can learn linear regression, it is important that you have a solid understanding of basic statistics. This includes concepts such as mean, median, mode, standard deviation, variance, and probability distributions. You should also be familiar with hypothesis testing and statistical significance. These concepts are essential for interpreting the results of a linear regression analysis. 2. Algebra. Linear regression involves a lot of algebraic calculations. Therefore, you should have a good understanding of algebraic equations and principles such as equations of lines and slopes. You should also be comfortable working with matrices and vectors as they are commonly used in linear regression analysis. 3. Calculus. Calculus is another important prerequisite for learning linear regression. Specifically, you should have an understanding of derivative and integral calculus. Derivatives are used in linear regression to find the slope of the line that best fits the data points. Integrals are used to calculate areas under curves, which can be useful when analyzing certain types of data. 4. Data analysis. One of the primary applications of linear regression is in data analysis. Therefore, it is important that you have experience working with data sets. You should know how to create graphs and charts that accurately represent your data, as well as how to perform basic statistical analyses such as calculating means and standard deviations. 5. Programming skills. Finally, programming skills are also a prerequisite for learning linear regression. While it is possible to perform some simple analyses using Excel or other spreadsheet programs, more complex analyses may require programming skills. Languages such as Python and R are commonly used in data analysis and can be used to perform linear regression analyses as well.